But this, honestly, this is going to look very similar to what you guys are doing. But okay, so first of all, when you're doing things like this, right, do you agree that suppose you couldn't find all of A1 up to AN and A, but maybe just every second term? Maybe I said, don't look at the whole sequence, just look at the terms A2, A4, A6, A8 forever. If inside that you find this kind of picture, that's still equally good for you, right?
Yes.
Yeah. Okay. So, I like the idea of having a block below a block. It's a great idea. So here's a starting question. This is not steps, stage one. To prove that you always have. So I'll say a 20 step, but it could be a 10 step, just some number. A 20 step of the form, the first 10 are all below the next 10.
Okay.
I'm not saying the 10th one's the biggest of those 10. All I want is all the first 10 are all the second 10. It makes sense? Okay. So, up step where the first 10 are all less than the last 10. It makes sense? That's a bit like what you're drawing over here. Except I don't care, well, it's fine to 10, but I don't care, it's just a 20 step, it needn't be consecutive terms. Okay. That'll be step one of the proof. And the reason that looks nice to me is we know that in general there's no actual increasing or decreasing 20 step. That's what there isn't even a 5 step, right? This is kind of a weakening of that. It's not saying I want 20 terms where I insist up, or down, down. All you insist is the first half less than the second half.
Sure.
That'll be step one. Okay. Then step two. But I can't prove step two either. So step two would say, take this 20 step. Here it is. So here are 10 numbers, here are 10, these are all less than that. Inside that, I'll look at exactly, I'm agreeing with you guys here, this annoying case in the steps where you want a 4-step which is 2 then 2. 3 then 1 you read by your Blauer thing, but 2 is the problem. So I would play, if you look at one of these, and you look at all the 4 steps of the form, a thing, a thing, a thing, a thing, one of those is increasing or decreasing. And then we'll be done. So I'm not even going to ask about a 4-step which is 3 here, 1 here.
No.
Because that kind of thing we know we can destroy.
Yes.
So again, here's the, of course 10 maybe it's 100. Why don't I'll write 200 to be safe. Because then I know there's no problem with 10 is too small, but it's half of 10 is 5 or something. Let me just, it doesn't know what number it is. Let's do it like this. So here's my beautiful 2-step proof, is I can't provide the step. Okay. So what we'd say, take any sequence, inside that, of course you can't find a 200 step that's increasing or decreasing.
No.
But can you just find a 200 step where its first half is below its second half? Okay. I should say all the way around, of course. It wouldn't matter.
No.
This would also be absolutely fine as well, of course. And you remark you have to allow decreasing. I'm sure you know this anyway. But otherwise, I take the sequence. I go, let's say, I go 10, 9, 8 down to 1. And then another block, where you go from 100 down to 101, down to 11.
Sure.
So a sequence of long blocks, and obviously where things go down. But of course, we know there's no increasing 4-step. Because you'd have to touch one of the blocks twice.
Right.
So we know, by this I meant either this or they're all first 10 are bigger than the last 10. Who cares which one? Okay. And that seems like a weakening of saying 200 all going down. I'd like that. And then, if you could prove that, then step 2 will prove it saying, whenever you have one of those, you're done. You'll not be saying that these are all possible 4 steps. Look at those that go 2, 2. I can't keep either step. I suspect that if either step was false, they can have an example. So I can't prove that, of course. So my guess is, if you could find me a clever kind of example to step 1, so if you can find me a sequence where there's no 200 step where all its first half walk, second half, or all bigger half, I kind of bet that somehow you think about it and you direct a 4-step thing, is my kind of guess. Because this is saying somehow along some 200 step, you're like going in blocks. So, and equally, maybe if step 2 is false, all these false as well. So suppose I said to you, I promise you I've got 100 then 100, and these are all bigger than all those. Look at the 2 2s. Can you always find what you want? I kind of guessed if you couldn't, you put blocks together, and each one do one of your larger sequences. I call them different things, but yeah, those things, and do things like that. So these are very similar to your ideas. When you drew, I was smiling when you drew things like this. It's so much like I think about as well.
Yeah, but if one of the blocks is going down, it's not kind of break the Lauge shuffle, because the Lauge shuffle it says that the block always goes up, down, up.
Oh no. But what I'm saying is, of course, in this, I'm saying this example, of course, there is a 4-step that's increasing or decreasing, but it's decreasing. So what I'm saying is, when I said I want to find a 200 with the first 100 less than the second 100, I didn't mean that. What I actually meant was, you always find a step where either all the first 100 less than the second 100, or they're all greater than the second 100. And what I'm saying is, I can't insist on doing, I cannot say, is it always true there's a 200 step where the first 100 less than the second 100, because of this example over here. Right? Here you can't even find a 4-step where the first 2 are less than the second 2, right? Because in any 4-step you go maybe here, then here, then here. Yeah. You always have somewhere you go down.
Sure.
Yeah. But in that case, if all the blocks are equal length, then why wouldn't you be able to have like one step in 4 different blocks?
No, it's only 2 blocks. Oh, in this picture, they're getting much longer. No, it's like your example. We take blocks getting long enough so that, deep breath, a 4-step can't hit 4 different blocks. So every 4 step is some block twice. But if you hit one block twice, you must be a decreasing 4-step.
Yeah.
So that's what I was saying. So I drew it this below, I meant below or above.
Okay. It's actually kind of gratifying to see that we've had the same ideas that seem to be like this.
They're very similar.
But we haven't.
Everything you do. I also love, but I thought 5 is very hard because my thought was finding a sequence of 6 steps is easy. Once you understood the 5-act problem, you know how your alarm works.
Yes.
Once I understood that, then I think finding a sequence of those 6 steps is easy. You say, oh, I'll put them together, always going up, always being longer, each one being the bad finite thing. So that happened. And that wrecks 6, but as you said, it doesn't kill 5. So I think this idea of saying, oh, let these blocks go up, down, up, down, up, down, is a really great, really clever idea, actually. Yeah, I was super happy I thought of that. I'm really impressed you guys thought that as well. That's really clever step, rather than coming and saying, we can kill 6 steps, we can't kill 5 steps.
That's really nice.
Genuinely very clever.
Good, because we always keep away from all kinds of literature. We never look at how other people do things. So it's actually interesting to see that we land the same place. Yeah. That's a really nice proof sketch.
I think none is written, that's...
No, it might not be written down at all.
It's not written down anyway.
Okay, fair enough.
Yeah, so these are very similar, because this and this is very much like your block thing.
Yeah.
Except I'm saying over a step thing. Which I like, so it makes it sound like original problem. It's like saying a 200 step that's increasing or decreasing, no chance. But can you merely insist these before those? Oh, and the first case I can't do, by the way, I can find in S1, I can definitely prove there's always a 4-step where either the first 2 are less than the second 2 or vice versa, but I can't do a 6-step. So I don't even know if you always find this or this. So I don't know if you always find there's a 6-step where all the first 3 are the smallest 3 in some order, or a 6-step where the last 3 are the smallest 3. And that's not, this should be so easy to do, but you don't test do it.
How odd.
It's really annoying. Really, really annoying.
It is a fantastic problem, but it is also an annoying one.
Also, lovely, you also thought the same thing, I thought the same, but I can take a beautiful picture, I admit. This lovely thing about saying, to kill a 4-step, it's enough to kill a 3-step that starts big,
Mm-hmm.
i.e. in your non-dead zone.
Yes.
Yeah. But do you guys also believe that that's true? So do you also believe that there should be, how should I put this? I need to get this. If there was a counter itself, supposing that you imagine for a second there is a bad sequence, that there's a sequence with no 4-step.
Mm-hmm.
Would you also agree that that would probably be because it doesn't have a 3-step in the safe zone? Or do you think it would be different?
I don't think so, because
Okay.
I think it is quite improbable that there are only hits down there,
Yeah.
because there is an infinite amount of 3-steps
True,
out of
true,
each
yeah,
hit,
yeah,
so
true,
it seems improbable that there
true.
are none in the first part.
Yeah. Okay.
And if not, yeah.
I guess, so I would guess, yeah, if it's all, I'd somehow, yeah, I don't know.
Well, the dead
The
zone.
triple thing might be key. The triple is non-dead zone might be the key thing.
The dead zone is not actually only just the bottom half, because if you take every second block, every second square of the first row, and every 2, and if you take the first 2 and then the next, skip 2, and then
True.
so you actually get some sort of like weird interference patterns. So
So all I'm saying was,
yeah,
if you have a 4-step, then if you look at its last 3 terms,
Yes.
they form, let's call it a big 3-step. So big means cases to them,
yeah,
i.e. in the life zone, not death zone. Yeah. So I don't even know how to prove that there's a, so I certainly can't prove there's a 4-step. There's always a 4-step that's increasing or decreasing hit, but I can't even prove there's a 3-step that's hit in this other zone over here. I don't know.
no.
Yeah, it's weird. But also, actually, I don't know any. I'm interested in what you're saying about 3, because of course for 3-step you've discovered that the imminent case you can do it. It's always some argument like you start somewhere and then you go to a point after which everything is bigger. And you have this nice thing with many infinite things, but it's always the same idea of you start somewhere, pause, then you go somewhere after which everything's bigger, and then you do something else.
Yeah,
I would love a different way of showing there's a 3-step.
yeah.
I don't know any way of showing a 3-step doesn't basically look around the start of the sequence somewhere.
Well, we were
And
talking
that's why
about the ends.
I would love to prove
Yeah.
that there's always a 3-step hitting the safe zone. There always is a 3-step which is big, where the jump is less than the case is near.
Yeah, I agree. We were thinking about trying to look at the last number in 3-step as using that as like the fulcrum of a 3-step, because then you have a finite situation before.
Right, yeah.
So that might, we were sort of thinking about this, but you're right, it would be wonderful.
But we did also think about the last number in 3-step and kind of made a proof that there will be it will end somewhere. But there's a number bigger than that.
Mm-hmm.
So,
Yeah.
yeah.
But yeah, so we disappoint you in the fact that we found the same proof for 3-steps than you have, so we didn't have anything nice to play with. I'm sorry.
Yeah, it's very easy doing it. Yeah. I like this picture. I love this picture of it as well, actually.
Yeah, it's a different way of seeing it.
Okay, that's a very nice picture. Yeah, but it's crazy problem.
It is really, it's so fascinating.
But I would thought that
Yeah, but it looks really elegant.
That's what it's saying. Does every sequence have a block structure?
Mhm.
Of course, it can't literally be block structure, because, like in your example, you go bigger, smaller, big, there's no really a block structure. Well, again, I guess you can say, here's a block, each block is, but you have a block bigger than a block.
Yeah.
And this is saying, you always have a block structure.
Yeah.
Maybe not in the whole sequence, but just in some finite part of it, and maybe just say length 100, not meaning you start somewhere and next, but jump of 10, 100 times. And the fact that I don't even know that is really depressing for me. So if you guys have any thoughts on, well, either those parts would be great, but especially I'd love to ask this one. Is it always true that well, basically it's like saying it's always true you can do this. You can find it like this.
Yeah.
But it just means some finite length, and it doesn't have to be consecutive terms, it can be these and then those, as long as it's a equal step thing.
Okay.
Say for 100 or something like that.
But if there is a step, since we know there's a proof that there are for a countable number, there is a way to make a sequence plus 3 steps. Then you kind of have to make these blocks of these countable blocks to get rid of these three steps in some kind of way, otherwise they just kind of.
Yeah, but is it true that only the way to get rid of those is to have a sequence of the four sort of stuff, then some bigger stuff, never coming back, then some bigger, then go back and so on? That's why I don't know.
Yeah, but I don't think it has to be that way, but it's kind of just congruent. Well, that argument down there works just if there's a sequence that's bigger than the other one. So it's kind of, it doesn't really matter if there's an even bigger one than that.
Right, but the question would be, this may not happen, but maybe this happens if you restrict to say every second term or every third term. That's why I want, so for me, I've got infinite down to say 200, but the key thing is, I'm not asking for 200 consecutive terms, something like this, just a 200 step that looks like that. So if your entire sequence looks like this, let's just look at the first two blocks. So if the entire sequence have 100 terms, and then 100 terms that are all bigger, I would say that's a great start, great success on step 2 of the proof. Now, of course, this needn't be true, but maybe somewhere, maybe if you look at the sequence and you start at time 1,000,000, then you have 100 and then 100 bigger. If that isn't true, maybe you start at 1,000,000 and you take every third term, like the 200th step, and then it's true. Just take one of those. But in some sense, writing this argument, I don't get a consecutive or every second or every third term. So I'd love to know that. And I like, this is attractive to me because it feels like the statement that we know isn't true, which is, can you always insist on a 200 step somewhere,
Right.
which is monetarily increasing or decreasing? That we know isn't true.
No.
But this is like a weaker version of that.
Mm-hmm.
That kind of makes sense.
Yeah.
And I say, if you do it for 4, then you do for, let me do it for 4. So, again, I'm looking at 4 steps. Again, we know that you, so how should I say this? Right. So we know that we don't know the answer for a 4 step.
Mm-hmm.
That's what we're trying to do here. But let me, remember, a 4 step means that you have 4 terms where they either go up or go down.
Mm-hmm.
Okay. Let me prove to you a weaker thing like this. So I'm going to tell you always find a 4 step